That's you can speed me along if you want as well, okay? So I'm going to use the value. I'm going to use x squared plus y squared plus 2gx plus 2fy. Yes. Yeah. Plus c equals 0. Okay. For circle 1, what's the g value? 2g equals 1. And next thing is, what's the f value? 2f equals minus 1. What's the centre of the circle for C1? Sorry? Minus 1, 1. G is 1. F is minus 1. Alright. What's the radius of the what is the radius of the C1 circle? So how do you find the radius? G squared plus f squared take away. See, g squared is going to be 1 squared plus what? Minus 1 squared minus 23, which is, I'm going to get 25, which is a radius of 5. So would everybody agree that this is the point minus 1, 1, and it has a radius of 5. Is that okay with you guys? Alright. Let's rack up the next part then. Okay. Oh, sorry. Don't need that part again. Alright, let's go with C2. What do we know about C2? Right. C2. 2g equals minus 14. So what does that mean for the g value? 2f equals 2y, so f will equal minus 1. Yeah, grand, right? What's the centre of its circle then? 7 and 1. Alright. It's handy. Now, what's the radius of this new circle? So what's its c value? C value of 41. Radius equals g squared, which is minus 7 squared plus f squared, which is minus 1 squared minus 41. That's square root of 9, which is 3. Is that okay? Now, when two circles touch each other externally, externally means that they touch like this. Is that alright? When that happens, the difference between the distance of the two centres is the same as the two radiuses added up together. Do you get that? So to prove that they touch externally, you need to get the distance between the two circles. Now what you know is about the y, you can use the distance formula if you want, but what can you say about the y values? Huh? They're the same, aren't they? They're just going to cancel each other out. The answer is 8. We already know the answer is 8, but here we go, look. 7 minus 1, which is essentially 7, plus 1 squared, and 1 take away 1, sorry. 1 take away 1 squared. The distance between the 2 points is 8. And if it touches externally, the distance between both points equals the radiuses combined. And does it equal the 2 radiuses combined? Yeah. Everybody cool with that? Did you all get that? I'll get that far. Alright, grand. C is a third circle. And both C1 and C2 touch K internally. Find the equation of K. Alright. Well, I think we're going to find this reasonably easy. Okay? I'll show you why. Here's a bit of a cheat. If these are on the same line, And see the way it stays at 1 all the time. Could anybody tell me what point this would be here? Alright. I see the issue. Give me a sec. Alright, can everybody see it now? If this point is minus 1, 1, this point here is this one here. What's 5 to the left of that point? Would everybody agree with minus 6, 1? It's another 5 to the left. Why do I not need to worry about the y value? Why do I not need to worry about the y value? Because it stays the same, doesn't it? If it didn't stay the same, it'd be a more difficult question, okay? Now, next thing. Can anybody guess the other red dot I'm about to put in here? Anybody like to guess this one? Add what's it called? Excuse me. Add 3 onto 7 and you get 10, 1. You cool with that? Now all of a sudden you have a circle, and you have a very big circle at that, and you have 2 points. You have one of them is 10, 1, and the other one is minus 6, 1. We know the radius is what? What's the full distance across here? 5, 5, 3, 3. Cut 16 and a half. 8. We know it has a radius of 8. What's 8 to the left of 10? We know the centre of the circle is 2, 1. So therefore, to get the equation of the circle, we can just use this here. To be fair to it, lads, I had a few layers to it. So that's h and k. And radius squared is 8 squared, which is 64. Anybody get it out? Alright, find the centre and radius of each of the circles and show that they touch externally. Alright lads, this is and the common tangent, that's the issue. The common tangent is probably the issue, is it? Alright. So, what's the centre of the first one? Anybody? 0, 0 and radius? 2. Centre of this one? So 2gx, so what's 2g is? G is 2f, f, centre of the circle, 4, 3, radius, so what's the radius, lads? 3, is it? C value of 16, isn't it? Radius is 3. Alright, we have all the information we need. Radius of 3, centre, 4, 3. Alright, how'd you prove that they touch externally again? Yeah, distance between both of them. So, if you imagine that's the centre of one circle, and that's the radius of 2. And 4, 3 is somewhere else, so 4 across 3 up, and it has a radius of 3, like that. Now, oh yeah, I drew that perfectly actually. That's 4, 3, and it has a radius of 3, doesn't it? You cool with that? So what point would, so yeah, perfect. Alright, so this is the way they're joined. You don't have to do the drawing, I'm just doing the drawing to explain what's going on. Radius of 2, radius of 3, so what's the distance between the two of them? What? 5. Now, how do I prove that the distance is 5? Distance formula. And we all know how to do distance formula, do we? Alright, you just distance formula 0, 0 and 4, 3, you get an answer of 5, and it proves it, okay? Anybody remember how to get common tangents? What is the common tangent, can you tell me? Is it this one here, is it? Is that your line there? You'd agree that's the common tangent? Alrighty. Now, I might be able to do this two ways. I'll see in a second, alright? Alright, Aaron? Yeah. We're going to try this two different ways, alright? Now here's my first way for you. Alright, my first way is, how do I get the slope of this yellow line here? Any takers? Yes? I get the slope of the blue line first. Does everybody know how to use the slope formula from 4, 3 to 0, 0? The answer will be 3 over 4. Is that okay? So the slope of the blue line is 3 over 4. Okay, so slope of the blue line is 3 over 4. What does that mean about the slope of the yellow line? Minus 4 over 3. Now, does anybody know how to find the purple point here? There might be a way to do it. 0, 0 goes all the way up to what? Try and stay awake if you can. Right? 0, 0 goes all the way up to what? 4, 3. Would you agree with that? And would you agree that that's a distance of 5? But I want a distance of 2 away, so what's that? Would you agree that's 2/5 of that distance? So what's 2/5 of 4? Because you go across 4 and up 3. So what's 2/5 of 4 and 2/5 of 3? Anybody? Sorry? Yeah, 8 over 5 and? So, would everybody agree that I have the point and I have the slope, don't I? So I have the point and I have the slope. So let's work this out. I know the point and I know the slope. I'm probably about to show you a really easy way after this, by the way. Does anybody know the really easy way? We'll see in a second. Alright. Simultaneous equations will only give me the point of intersection, I believe. So just leave it with me for a second. Alright, what point is on the tangent, people? What point did we say was on the tangent? Sorry? Okay. Now, what the hell am I doing here? Minus 4 over 3, yeah? And then what's it? X minus A over 5. Okay. What's the common denominator here? It's probably going to be 15 in a second, is it? Whoa. What's that? 32 over 15. Anybody get this far? Alright. Common denominator, lads? What's common denominator? So what do I do when I add, so multiply both, I put everything over 15. So what happens to the y? What happens to the 6? 18, yeah. What happens to the 4x? Minus 20x, yeah. What happens to the 32? Okay. Move it all over one side, what do we get? 20x, yeah, what else? Minus 2y, and then here? Minus 40. Divide them all by what number? Divide them all by what number? 5, and what do I get? Alright. Anybody know a much quicker way? Come on, Dylan. Go on, show everybody. One circle, take away the other circle will give you that. But it's nice to know about methods though, isn't it? It's nice to know that there's a valid method But then if you take both circles away from each other, you'll get the same answer. Let's find out. So Dylan was sitting on that information, knew it well. So see this circle here? To get a common tangent of a circle, just take the two circles away from each other. That's one circle. And then take the other circle away from it. Everybody alright with that? Add downwards and what do I get? Oh, sorry, which one's equal to 4? On the other side? So that's minus 4 then, yeah? Thanks. And then we get minus 8x minus 6y plus 16 equals minus 4. Multiply both sides by minus. Bring the 4 over the other side, it's going to be minus 20. Is it the same equation? No, it isn't. What did I do wrong here? So give me a look. 16 minus 4. 20. Sorry?
Minus 50 instead of minus 40.
Here?
Yeah.
So if we divide this by 2, what will I get? What's the answer in the back? So that's the correct answer, right? So this answer here contained a mistake, okay? So what we're going to quickly do is you're obviously going to take the two circles away from each other in future, alright? But I'm just interested to see what we did. Sorry?
Minus 32, minus 18, minus 50.
Sorry, alright, so just give me 1 second there, alright? Ah, do you say that's minus 50?
Yeah.
Thank you. And then divide that by 5.
Yeah.
So the method was perfect, bar the 32 mixing with the 18. Okay? So you can see that both methods give you the same answer. One method is considerably faster than the other, correct? That's the method you use. Take the two circles away from each other. Okay? But it shows you it can be done many different ways. Right. A circle passes through the origin and the point 4, 2. If its centre is on the line x plus y equals 1, find its equation. Now, what does that mean exactly? Now, I'm going to draw myself a picture because I like to understand what exactly I'm looking at here, okay? So, would everybody agree with y equals mx plus c? Yeah? Would everybody then agree with y equals minus 1x plus 1? What did I do there? Brought the x. What type of graph is that? It's a line that has slope of 1 and crosses at the point. Would you agree that it crosses at the point 0, 1? And would you also agree that it's a line that goes at a 45-degree angle downwards? Okay? What's the next piece of information I have? The point passes through the origin, which is 0. What other point does it pass through? 4, 2. So for argument's sake, somewhere up there, yeah? Okay? And I'll show you what this sort looks like. Here. Actually, excuse me. I think it's going to look more like this actually. I'm just going to grab my circle. I'm going to delete it. Just going to delete my circle for a second. I think it looks something like this. I'm just not reaching that one as quickly as I'd like. 4, 2. For argument's sake, that's 4, 2. Is that alright? Does that fit the description of your question? The center is on the line, yeah? and both points are contained within this. So what type of question is this is what we're getting at. Okay? So actually, sorry. What is the centre of the circle, otherwise known as minus g minus f? Would you agree with that? And minus g minus f is on the line x plus y equals 1. What does that mean when I sub in minus g and minus f? What does that automatically mean? Automatically means minus g minus f has to equal 1. Is that okay with you guys? Pause it there. Who's lost me? Elvis. So what I was trying to get at is that this line here contains the centre of the circle, and it also contains 2 points. The circle itself contains 4, 2 and 0, 0. Is that okay with you guys? Now, because I know minus g minus f is the centre of the circle in terms of g and f, I therefore know that if I replace x with minus g and y with minus f, it has to balance, okay? So I know that that's minus g minus f equals 1. The next piece of information I'm going to use is this. The next piece of information I'm going to use after that is the following. I'm going to use x squared plus y squared plus 2gx plus 2fy plus c equals 0. Right? I need to pick a point that's on the circle. What point is on the circle? What other point is on the circle? I'm going to use 0, 0 because it's really easy. X squared, 0 squared. Y squared, 2g times 0, 0. 2f times 0. And the c value. So what do we find out about the c value? C value equals 0. Okay? The next thing I'm going to do is I'm going to use the point 4, 2. So what about the point 4, 2, lads? What is it? 4 squared plus 2g times, what's it? 4 plus 2f times 2 plus c equals 0. Now what can we get here? Sorry, I'll just multiply it all out. 16 plus 4 is 20. What do we know about the c value? So what do we have here? 8g and now we have 8g plus 4f equals minus 20. That is a half of a simultaneous equation, isn't it? And what about the equation we got earlier? That one there, isn't it? And we're just going to put them both together. Okay. See this one here? I'm just going to divide that by 4. What happens if I divide it by 4? Yeah. Yeah. And what am I going to get? G equals minus 4. Okay. And if g equals minus 4, what's the f value then? So that would be minus 32, won't it? And 4f will equal 12. F equals 3. Does it ask me for the equation of the circle? It does ask me for the equation of the circle. So, anybody, how do I finish this off then? Yeah. Minus 8x, yeah? Plus 6y, c value is 0. You all good? Okay, let's keep going. Didn't get around to it. Which one do you want more? 12. Alright. So what have we done so far? Just 7, 9 and hopefully a bit of 12. 5 as well. Alright. C. Alright, what's the radius of C? 1. What's the centre of C? Would everybody agree 4, 5? How do we know it's 4, 5? I used the HK equation, and you see that H is equal to 4 and k is equal to 5, which means the centre of the circle is 4, 5. We all cool with that? They're all identical sizes, aren't they? So everything here has a radius of 1. Now, I'm about to show you a little trick here. 1 across, 2 across. How far underneath H are you now? You're directly underneath H now, aren't you? So what does that mean about the x coordinate of H? 6. You ready? Let's go upwards, if we can. Right. So see this line here? 1 radius. Okay. That is tough actually. Wait. I think I have a better way of doing this. How many radiuses is that? Do a bit of Pythagoras theorem, I think. So how many, what's that? 1, 2, 3. Would you agree with 4? Okay. And if that's 4, and we all agreed that's 2, did we? If that's 4 and that's 2, I can probably find the distance of this blue line then, can't I? And we know what the distance of the blue line would be then. What's it? 4 squared plus? Sorry, 4 squared equals 2 squared plus, call it h squared. Oh, sorry, h is already in use. Call it x squared. And 16 take away 4, 12. What's the square root of 12? 2 root 3. Is 2 root 3 okay? Now, here's the issue. Okay? Can anybody tell me what point the green one is? If this one's 4, 5. If the first green dot's 4, 5, what's the second green dot? 6, 5. And what's 2 root 3 above 5? Anybody tell me? What's 2 root 3 above 5? Just 5 plus. Is that the answer in the back of the book? What is the answer in the back of the book? Is it in decimal? Oh, sorry, Rassford equation. Alright, grand, yeah, I'll do that now. Ready? Now, how do I find the equation? X minus h squared plus y minus k squared equals r squared. Alright, let's see if this works out. Yeah, this is a valid answer. I'm about to give it to you. X minus 6 squared, yeah? Y. Now what's this number when you minus it? It's minus 5 minus 2 root 3. That's my answer. Is that what it has in the back, or? Yeah, it's perfectly valid. Who's completely lost? I'll give you the idea, okay? Here's what I'm suggesting. Okay? I'm suggesting you make yourself a triangle. Everybody see the triangle? Everybody see that triangle, yeah? Now, here is my suggestion. Does he use trigonometry? We haven't done trigonometry yet, so therefore I can't use this in your test. Therefore, we'll do it another time. I was going to have to use trigonometry and the area of an arc formula. In theory, here's what I'm going to do. I get the area of the big triangle. Everybody see the area of the big triangle? I get the area of that using a half base times height. Then I find out what this angle here using trigonometry. I get the area of the pizza slice in here. Then I know the area of this pizza slice. I do the same thing to find the area of this pizza slice here. And then I add on three semicircles, isn't it? Does everybody see the 3 semicircles? And The triangle, take away the 3 pizza slices and the 2 semicircles, gives you the area that's trapped in between. The end.